Remember, again, the goal of this unit in trig is to get to a point where we can evaluate certain trig ratios and solve certain trig equations. Okay, but we need to do a lot of prep work before then. And today we're going to talk about a new type of angle measure besides degrees. But before that, remember I talked about how we can use a coordinate grid to draw any size angle. Okay, and when we did a starting position of the ray, it is just simply one arm of the angle. Okay, that's the initial arm. After we measure, okay, and stop where we want to measure, we get a second ray for the terminal arm. So here, this would be our initial, like I talked about last lesson. This would be our terminal. And depending on how we want to measure, usually we're used to measuring from the initial to the terminal in a counterclockwise direction. And then we would measure in degrees. Okay? And we'd always get a positive answer for the angle. It is possible to measure negative angles. You would just go in the other direction. So your initial arm, you would go clockwise. And this would actually be a negative angle. Because really, whenever you draw an angle with or without a coordinate grid, you're actually drawing two angles all the time. So if we go in a clockwise direction, the angle is going to be negative. So for example, if this, say, was 40 degrees that we measured, there is a relationship between the positive angle from initial to terminal in counterclockwise direction and then the clockwise direction. If we move 40 this way, we'd have to move negative 320 the other way, because the two angles without the negatives have to add up to 360. Okay. Okay. So this new type of angle measure called radians. Okay. What exactly is a radian? Why do we use it? Well, technically, a lot of times when we use certain trig formulas to find things, we use angles that are measured in radians. We don't use angles that are measured in degrees. We don't have a formula for that. Okay. It's kind of like when, you know how whenever you're asked to find a percent of a number, you don't punch a percent into your calculator, you change it to decimal. It's kind of the same thing. Okay. All right. So angles can also be measured in radians. And how much is 1 radian? Well, we need a circle to do this. Okay, so if we put an angle inside a circle, 1 radian would be if the radius of the circle is 1. Okay? The arc length, the measure of this angle in radians, will be equal to the radius of the circle. So if this is R and this is R, this length would also be R. So if this was 1 unit, centimeters, meters, whatever, okay, this curved length here, this arc length, would also be 1. So when the arc of a circle has the same length as the radius, the measure of the set what? That doesn't make sense. measure of the angle should be in there, is 1 radian. Okay, so how many radians would be in a complete circle? So how many radians would be in a complete circle? Well, how much is a complete circle in degrees? 360 degrees, right? Okay, so we know that, but how many radians would that be? Well, if you think about it, this is also the circumference. What's the formula to find circumference? Do you remember? It's been a while. Sorry? That's area. 2 pi r, I heard. Or, yeah, 2 pi r. So if we divide the length of the circumference by the radius, we're left with how many radians are in a circle. So it would be 2 pi r divide r, which means there are 2 pi radians in a circle, which would be approximately how much? Well, 6 point. Normally pi we say is 3.14, so about 6.28. So a little over 6, right? So in a complete circle, there's 2 pi or a little over 6 radians. Okay? Whereas with degrees, there's a lot more degrees in a circle. Not as many radians in a circle. So that's the first conversion we've done. 360 degrees is the same as 2 pi radians, or about 6.28, which is 1 revolution of the circle. Okay, so that's your very first conversion. And if you know that, you can get all the other conversions between degrees and radians. For example, how many radians would 180 degrees be? If we know this. Just pi, right? Because when we divide 2, 2 pi divide 2, because this is 360 divided 180 is 2. So that means there'd be pi radians, or about 3.14 radians in half a circle, or half a revolution. How many radians would be 90 degrees? Well, we could use this or this. Half of pi, or pi over 2. And that 90 degrees, or pi over 2 radians, is a quarter of a revolution. And 45 degrees, wouldn't it be half of this? So I would do pi over 2 divide 2, which is the same as pi over 2 times a half. Remember, dividing 2 is the same as times a half. It's pi over 4. And that would be an eighth of a circle. So right now you've got 4 conversions. 360 is 2 pi, 180 is pi, 90 is pi over 2, and 45 is pi over 4. But we want to be able to do any one. Okay? So we want to find a way to convert between degrees and radians. And we use this to help us. Actually, we use this one to help us even more. But just remember, if you are given an angle measure and there's no units, assume it's radians. So if I said an angle measure was 10, don't think degrees. It's only degrees if I put the little degree symbol. If I say 10, it's 10 radians, which is a very different measure in degrees. Okay. Before we do conversions, let's just sketch a couple. Okay. Let's sketch a negative angle in degrees and then a couple of positive angles in radians, because you notice there's no degree symbol here. So I assume these are radians. Well, how would I sketch 165 degrees? Well, this is my initial line. Which direction am I going to go to measure a negative angle? Clockwise, right? So you've got to kind of think backwards. This is how much to here? Negative 90. This is how much? Negative 180. But I need, this is a little bigger. So wouldn't it be somewhere around here? So that's negative 165 degrees. You don't measure positive 165 and then draw the negative one. You've got to sort of think backwards. Use 90, 180, 270 to help you. So you're going to have to get used to dealing with fractions as radians, because we do a lot of radians that are given in fraction measure involving the pi symbol. Okay. Well, first of all, it's positive, so I'm going to go this direction. Here's my initial line. The question is, how much do I go for 5 pi over 6 radians? Well, how many radians? Sorry, no, I don't have it. If you want to think of this in degrees, you can, or you can think of this in radians. 5 pi over 6. Well, if you think 6 pi over 6 is how many radians? Just do the division. Pi. Right? And how much of a circle is pi radians? Half a circle, right? So this would be 6 pi over 6. Okay? This is going to be a little bit less. So I'm going to go somewhere around there for 5 pi over 6. We'll do a lot more of that, trust me. And finally, 1.2 radians. Well, again, think, so now think instead of pi, think numbers. How many radians are approximately in a complete circle? 6.28, right? Okay, or 2 pi radians. What about half a circle? 3.14. What's half of 3.14? About 1.6. So wouldn't this 90 degrees be about 1.6? And this is going to be a little less. So 1.2 radians would probably be somewhere around here. You don't have to be perfect. Sorry, I should draw arrows here because the directions. You could be asked to sketch an angle in degrees or in radians. Okay, seen them before. Okay, let's talk about converting. How do I convert from degrees to radians, and then how do I go backwards? Well, if we know 180 degrees is half a circle, or pi radians, if I divide each of these by 180, 1 degree is going to be pi divided by 180. So 2 degrees would be this times 2. 5 degrees would be this times 5. 45 degrees would be this times 45. So whatever your angle measure is in degrees, you multiply it by pi over 180 to get to radians. Okay? Whoa, stop it. Can you tell us? Now it's really messed up. Wait a second. It's all over the place. Fine, reset page. Oh, that helped. Ay, ay, ay. Okay, let's see if this works. Just want the little haywire on me, just all because I picked the highlighter. Peace. Try this. Which one should I pull out? This work. Oh, yes. No, it's not letting me do the highlighter. Okay, so I'm just gonna. Cheat a little bit. Okay. So let's convert all of these to radians. And notice that it says you're going to give your answer two ways. As an exact value, which means you're going to leave it as a reduced fraction. And then you're going to use a calculator and then round it to 2 decimal places. So how do I convert 30 degrees to radians? I just times by pi over 180. Remember, this is the same as 30 over 1. And when we multiply fractions, we can reduce before we multiply. I can pick any numerator with any denominator. What could I divide 30 and 180 by, the largest number, to reduce it? What can I divide both 30 and 180 by, the largest number? Can I divide them both by 6? Yes. Is there a larger number? 30. Right? 30 divided 30 is 1. 180 divided 30 is 6. So that means your answer would be pi over 6 as an exact answer. As an approximate answer, you would just do pi divided 6 on your calculator. And you would get approximately 0.52. So only about half a radian. Under 20 degrees. What could the largest number I could divide into 120 and 180? 60. 2, 3. So I get 2 pi after I multiply over 3. And then if you actually punch in 2 times pi divided 3 on your calculator and round it, you're going to get about 2.09 radians. 250, again, just toss it over 1, times it by pi over 180, and see how much you can reduce. Any idea? It's a bit of a tougher one. Does one number jump out at you that you could divide by? 10. Okay, so it's okay to reduce more than once if you need to. Let's just try 10. So we get this. Well, I can't reduce 25 and 18, can I? There's no number I can divide by. So that's the best I can do. So it's going to be 25 pi over 8. Which, again, if we use a calculator and approximate it, we get approximately 4.36. Okay. Negative 300 degrees. Well, don't let the negative throw you. Just remember to put the negative in your answer. 30? Yeah, that'll work. Is there something higher? 60? Like 60 might do it. We get 5 and 3, which can't be reduced more, so it's negative 5 pi over 3, which, if you use your calculator and convert it, gives you approximately negative 5.24. Notice I'm not writing any units after that because it's radians. And finally, 270. Remember, if you don't find the highest, it's okay to reduce more than once. Okay. 10? Okay, let's try 10. 9. So you get 3 pi over 2. That's what I mean. It's okay to reduce it a couple of times if you need to. If you found the highest, it would have been 90 in the first place. And then this one is approximately 4.71. Okay. So notice you're going to have to do some work with fractions when we're dealing with radians and degrees. And you're going to get to a point where you're going to know very common ones off the top of your head. Like you're going to know 30 degrees is pi over 6. You're going to know 180 degrees is pi. You're going to know that 315 degrees is 7 pi over 4. Okay, you'll get to know these. We're going to revisit the unit circle. Oh, now I'm blocked. Oh, you took out this page. Note that. Oh, yeah. Can I restore it? Reset page. I reset it to nothing. Ah, good. All right. We'll just have to get back in there again. There we go. Okay, so how do we go the other way? Radians to degrees. Well, remember, okay, from radians to degrees, we
just saw that we multiply by pi over 180. Well, if you go degrees to radians, you just go backwards. And what's the reverse of multiplication? Division. So you divide by pi over 180, which is the same as multiplying by 180 over pi. Okay? All right, these ones with degrees, we're not going to leave them in fraction form. We're going to leave them either as exact answers or we're going to go to decimal. So again, you would just do times 180 over pi. And let's do some reducing. Any numerator with any denominator, what could I reduce? Sorry? Yeah, I can divide both those by pi. Those are gone. Those will always be gone. And then 180 divided by 4. You can reduce it or you can just do it. 180 divided by 4 will give you 45 degrees exactly. So you could just do this and then do the actual division. Or you could reduce it and you'd end up with 45 over 1, which is 45 degrees. Remember, write that degree symbol. Notice when you do it this way, and if you're given the angle in radians with pi in it, the pi's will always be able to reduce or cancel each other out to 1. So for this one, you could try and reduce. It is possible to reduce. You could divide both of these by 5, or just do 3 times 180 divide 5. Okay? So you could just do this, which gives us what? 540 divided 5, 108. 108?
Yeah.
8 degrees exactly. This next one, we're given the radians not with pi in it, but just as an approximate, or just 1.8 radians. So this one would just be a straight calculator question. You just do 180 times 1.8, divide that answer by pi, and I believe I said nearest hundredth, so 2 decimal places will give you approximately 103.13 degrees. This one, times it by 180 over pi. Remember that negative is going to be a negative in the answer. So the pi's go. 180 divided 6 is going to give me 20 and 1. So I'm left with negative. Oops. Times 5. Yes, it is times 5. Yeah, because I didn't cancel this out. So 5 times 20 gives me negative 100 degrees. Okay, I want to talk about one more page. Something called coterminal angles. Co means share, terminal means the end arm of an angle. So coterminal angles, they're angles that share the same terminal arm. Remember, the initial arm is always the positive x-axis. And notice I've got a terminal arm going into quadrant 2. All of these are equivalent to these. So like if I went from here to the terminal arm, that's about 100 degrees, a little past 90. But what if I went here? How much have I gone so far? 100, and then I went like this. How much have I gone now? 100 plus 360. So this, notice we can go past 360 degrees. So that's a 460 degree angle, which is equivalent to 100. It's coterminal with 100 degrees. Or I could have gone in the negative direction to get to this terminal arm. And if I went 100 this way, and a complete circle is 300, I must have gone 360 minus 100, which is negative 260 degrees. So notice all of those have the same terminal arm. So we would consider them all coterminal. So how do you find coterminal? Well, if it's in degrees, keep adding 360 or keep subtracting 360. If it's in radians, keep adding a complete radian, a complete circle. How much is a complete circle in radians? Yeah, or in terms of pi? 2 pi, right? So you would add 2 pi to get a coterminal, or subtract 2 pi, and you could keep adding and keep subtracting. So like I could have done this to go 100 plus 360 to get this. I could have gone around again plus 360 to get 820 degrees. I could have done 260, 100 degrees minus 360, which is negative 260, minus another 360, minus another 360. There's infinite coterminal angles to any angle. So if it's in degrees, keep adding or subtracting 360 degrees. If it's in radians, keep adding or subtracting 2 pi. Sometimes you won't be asked, like, if you're asked to name all coterminal angles, you would be writing forever. Because you'd have to keep adding 360 or 2 pi forever, or keep subtracting 360 or subtract 2 pi forever. Okay? There is a certain notation we can show that, which is at the bottom. But a lot of times you're asked, okay, find the coterminal angles, but all the ones within these intervals. Okay? So I want to find coterminal angles to these. One's in degrees, the other 3 are in radians, that are between 0 and 360 degrees, or in radians between 0 radians and 2 pi. These are the same. Okay? Between 0 and 1 revolution of the circle, between 0 and 1 revolution of the circle. So I start out with a negative angle. Remember, you can add 360 minus 360. Should I add or subtract to get in this interval? I need something positive. I have to add. So negative 130 plus 360 gives me 250 degrees. Is that right? No. What am I doing? 230. Is that within here? Yes. So that's an effort. If I added another 360 to get another coterminal, would I still be in here? No. So I stop. This is the only one that works. Getting the idea? 8 pi over 3. Okay, this is where you've got to be able to deal with fractions. Is this inside this interval? Is it bigger?
Or is it smaller? Obviously, it's not smaller because it's not negative. But is it past 2 pi? Well, think of, whenever I see a question like this, I always use these as a reference. 3 pi over 3 is pi radians, and 6 pi over 3 is how many radians? 2 pi. So is 8 pi over 3 bigger than this? Yes, right? Which means I've got to subtract to get in this interval. So I've got to do 8 pi over 3 minus 2 pi. You got to know how to subtract fractions, so you got to put common denominators. 8 pi over 3 minus how many pi's over 3? 6 pi over 3, because we times by 3 times by 3. And I get 2 pi over 3. Is that inside here? Yes, because it's bigger than 0. Remember, 2 pi is the same as 6 pi over 3, and it's smaller, so that works. If I were to subtract another 6 pi over 3, what would I get? This minus 6 pi over 3. I'd get a negative, but that's not allowed. So I stop there. Okay? Now the pi over 2's, actually you don't even really need this one for these questions. How many pi over 2's are in a complete circle? How many pi over 2 gives me 2 pi? 4, because 4 divided 2 is 2. What else do I need here? A pi. Okay. So this is negative, which means I'm going to have to add a complete revolution. Well, remember, a complete revolution is 2 pi, but as a fraction over 2, it's that. What do I end up with? Negative pi over 2. Is that in here? No. Which means I got to go again. I got to take the negative pi over 2 and add another complete revolution. And I get 3 pi over 2. Is that in here? Yes, because remember, this is 4 pi over 2, right? If I were to add another 4 pi over 2, I'd get too big, wouldn't I? So I'm done. $19 pi over 3? Well, I want to remind myself 2 pi is how many pi's over 3? Well, we saw it from here. So is this too big? Yes, it's too big, right? Because it can't go past 2 pi or 6 pi over 3. So I got to subtract the 2 pi over 3, 6 pi over 3. And I get 13 pi over 3. Is that still too big? Yes, it is. Because it has to be lower than 6 pi over 3. So I got to minus another 6 pi over 3. And I get 7 pi over 3. Too big? Yeah, just a little. So I've got to go one more. 7 pi over 3 minus another 2 pi, or 6 pi over 3, gives me pi over 3. That's okay. But if I tried subtracting again, I'd get into the negatives, which I can't have. Okay? This next one is very similar, but the intervals are different. In degrees, as long as it's between negative 360 degrees and positive 720, it's good. In radians, and these two are equivalent, okay? Negative 360 degrees is the same as negative 2 pi. 720 is 2 360s, or 2 2 pi's, which is 4 pi. So, 220. That's in this interval. If I add 360, will I get an answer that's still in this interval? Yes. What do I get? 580. That's inside. If I add another 360, will I still be inside? No. So don't add anymore. Go back to the original and start subtracting. What's 220 minus 360? Negative 140. Is that in the interval? Yes. If I were to subtract another 360, no, it would get too small. That would take me past this. So those are the coterminal angles. These ones, fortunately, they're all over 3. Remember, 2 pi is the same as 6 pi over 3. Use this as a reference. So negative 2 pi would be negative 6 pi over 3. And 4 pi would be 2 of these, right? So what's 6 pi over 3 and 6 pi over 3? 12 pi over
56.
oh. When we subtract fractions, the denominators stay the same. We only subtract numerators. Okay, so is this between this? Yeah, if I were to subtract a 6 pi over 3, would I get outside this? Yes. So don't even bother subtracting. But if I add, right? What do I get? 1 pi over 3, or just pi over 3. Is that between these two? Yes. Looks like I could add again. And I'd still be within this interval. So pi over 3 plus 6 pi over 3 is 7 pi over 3. Is that still in? Yep. But if I added another 6 pi over 3, I get 13 pi over 3, which is outside. So those are the only two. Four pi over 3. Is that inside here? If I added a revolution, 6 pi over 3, would I still be in here? Yes. If I added another 6 pi over 3 to this, I would get outside. So don't even bother adding anymore. Go back to the original and start subtracting. What does that give me? Negative 2 pi over 3. Is that inside? Yeah. If I subtracted another 2 pi over 3, would it still be inside? No, it'd be negative 8 pi over 3, which is outside.
Is this inside here? No, too big or too small? Which means I gotta start subtracting. Oops, 19 by 3. What do I get? 13 pi over 3. Is that good? No, still too big. So I gotta take this 13 pi over 3 and take away another 6 pi over 3. And I get 7 pi over 3. Is that good? Yes. Looks like I can go again. 7 pi over 3 minus 6 pi over 3. What does that give me? Sorry? 1 pi or pi over 3. Is that good? Yeah? Looks like I might even be able to go again. This is crazy. What do I get? Is that good? Yep. But if I went again, no. So this one has 3 coterminal angles. Finally. And this is just notation that you have to remember. What if you were asked to find all coterminal angles? There was no restriction in the integral. Very straightforward. If it's in degrees, write this, pi plus 360 times k, where k is any integer. And we represent that by the letter z. If it's in radians, instead of going 360k, do 2 pi k. So what that means, for the above ones, I would just go 220 degrees plus 360k, where k is an integer, KEZ. That represents all of them. Because if you think about it, how do I find all of the coterminal angles? You keep adding 360 forever, right? Or you keep subtracting 360 forever. Well, if I multiply by 1, and then that's adding to 360. If I multiply by 2, that's adding 2 360s. 3 is 3 360s, and so on, forever. If I multiply by -1, that's subtracting 360. If I multiply by -2, that's subtracting 2 360s, and forever. So that's why we can use this notation. If it's in radians, you do the same thing, except you replace 360 with 2 pi. So these ones would be -5 pi over 3 plus 2 pi k, KEZ. This one would be the original angle 4 pi over 3 plus 2 pi k, KEZ. And this one would be 19 pi over 3 plus 2 pi k, KEZ. You just have to remember that notation, okay?